Mike Mucci, Vice President of Engineering and Service for Butler Automatic. And we're here today to talk about our SP1 splicer for the film packaging industry. The Butler SP1 splicer, like most Butler products, allows you to run your process uninterrupted. We have an accumulation of material in the back of the splicer that will feed the process at line speed, allowing you to change into a new roll of material and automatically splice from the prior roll of material that expired. So I'm going to go ahead and load a new roll of material. Typically this roll would be feeding the process downstream through the accumulator and running at line speed. The operator would load a new roll. We have a number of different ways to load rolls. This is our lift elevator, where the roll can be lowered to an easier load height and then raised into position after it's loaded. The operator simply swings the roll into position and begins the splice preparation process. So with the new roll of material loaded, the operator will now prepare a splice. The lower roll will be feeding the process at line speed. The accumulator is full, so the accumulator can feed the process during the splice cycle. So to prepare the splice, the operator will open the splice head. The vacuum will turn on automatically. The tape dispenser on the side of the splicer has graduated marks on it that correlate to the width of the web, so they know exactly how much tape to cover the width of the web. Tape gets placed on the vacuum bar. The material is brought forward to the leading edge of the stainless bar. The operator puts some slack into the roll so he can close the splice head without moving the splice out of position. They lower the roll drive. And when everything on the HMI is green, it means the system is ready to prepare a splice. We're not running the lower drive right now to feed the process, but when I press the manual splice button, you'll see that the running roll will now retract material pulling back from the process. It's looking for the registration mark. Once it finds the registration mark, it will advance an appropriate amount, automatically make the splice, and the splice will be in registration. So I'll initiate the splice process by pressing the manual splice button on the HMI. The running roll will run backwards till it finds the registration mark, automatically make the cut, and the new roll of material is now feeding the process. Alright, so on this particular SP1 splicer, we have a number of new enhancements and features that we added over the past year to 18 months or so. We'll start with the HMI, where we've improved the graphics quite a bit. They're much more intuitive in terms of what is visible to the operator. Some of the new features that we have here include a little clearer indication of the roll drive positions being up and down, as well as messages that will come across to let you know that the roll drive is not in the correct position. We have information here about the pitch, which is the distance between the eye marks on the web. So if you're using in-registration splicing, that actual distance will be recorded there. That way the operator in monitoring that can understand whether or not perhaps the sensor is no longer in the correct position. On the HMI, we also have the arrows for the side lay capability, which can move the entire splicer left or right to keep your web in line with your process. That's handled by an actuator that's on the bottom of the splicer, pushing off of the base of the splicer. And if I move that button, which I'm going to slide over here, you can actually see that the base will slide, the entire machine will slide left or right on the base of the splicer. And this allows you to keep your web in line with your process, and the operator can manually use those adjustments to keep it in line. And WAVE is an acronym that stands for With Adaptive Vacuum Effectiveness. And what we've done is the tape that will hold the splice and be prepared to the splice is held by this preparation bar, the stainless preparation bar. And by having these wave formations in this profile emanating from each vacuum hole, it allows us to cover vacuum over this entire range versus in discrete positions where the holes had been located previously. As a result, if you were to have a web that might end, let's say, somewhere between these two vacuum holes, or maybe very even close to the outside one, the edge of that web would not be held by the vacuum for that last inch or so. By contrast, here on the wave bar, this vacuum will carry all the way across through this wave profile, so if the web ends anywhere on that profile, you'll still hold down the edge of that web. So it's a much more effective method. Another feature that we added into the preparation sequence is a vacuum sensor on the nip bar. And what that does is it will monitor whether or not the splice has stayed in position. What can happen is if an operator closes the splice head but has not left enough slack, and they close the splice head and the web pulls back off of its vacuum bar, we will sense the loss of vacuum in that nip bar, and it'll automatically alert the operator that the splice is no longer prepared. So another feature that we've added recently to the Butler SP1 splicer is this adjustable exit idler. And what we found through years of implementing these splicers in the field was that when we would retrofit this to an existing line, we may have difficulty getting information either from the customer or from whomever exactly how high the exit idler needs to be to line up with the downstream process. This would require back and forth with the customers to try to find out exactly what that dimension was, and then put custom holes in our frame and position brackets to hold this in the correct location. If we got on site and that location was incorrect, there was a lot of rework required. The adjustable exit idler now has the capability of being relocated into several holes that already exist throughout the height of the splicer frame. And then within this range, the brackets that hold the idler can also be moved up and down within the range. So by providing this one assembly to every customer, we can provide exit idler distances from near the bottom of the splicer all the way up to the top without having to make any field modifications other than moving and relocating the hardware. So another part of the new graphic systems that we have here is a little more intuitive way to get to some of the menu settings for running the splicer and making changes to the way it operates. We've talked previously about the different automatic splice techniques that we have. You can see here that it is currently set to diameter, which is the graphic that is shown here in the center of the screen. If you wanted to do automatic splice by some other means, you can access the main menu, go to splice mode, and you can see that we could change this to core sense, which is another piece of hardware that we'll be describing, end of roll color tape or reverse whiff or some other capabilities that we have. We also have the ability to teach the registration sensor remotely, as well as changing the position of where the cut is made relative to the eye mark to better suit where you may want the splice to appear in your package. So another feature of the Butler automatic splicer, one of the ways we can activate automatic splice is using the core sensor, which is the sensor that you see mounted to the side of our drive housing. So the drive housing pivots down and changes its position as the roll diameter gets smaller. That sensor is looking for the core of material to become available and become visible. As soon as the material unwinds to the point where the cardboard core or colored core becomes visible, it immediately initiates the splice sequence. It will then reverse the roll direction as we described in the splice sequence, find the registration mark, and perform an automatic in-registration splice. That is probably our most cost-effective method by which to do automatic splicing because it brings the material all the way down to the core, utilizing all of the material.